Hello everyone, and today I'm going to show you how to set up this cute little beast, the msp430 G2 launchpad kit, which has M430 G2 553 IC installed, and not the crystal oscillator. Crystal oscillator goes into these two holes, and I haven't installed them yet. Alright, so we'll be trying to configure this today with IAR embedded Workbench. Interestingly, they got a couple of free versions or free restricted versions available, so make sure you are connected to internet and go to IAR embedded Workbench. Just type, I'm sorry, spelling mistake, Google will pick it up. Alright, there we go. And make sure you have at least 1 GB of RAM in your computer. And if you're running Windows XP, make sure you have Service Pack 3 installed. For Vista, Service Pack 2. For Windows 7, Service Pack 1. When Windows 8 and 10 users needn't worry much about it. Alright, so yeah, these guys support a couple of different brands, should I say. Alright, we got here tools for msp430. You can even click here. Alright, so showing tools. It's loading. Scroll down. Yeah, there we go. Download a free trial. That's what we want. Alright, so click here to download the software. Interestingly, I got one already downloaded. Let's go to download folder. Yeah, there we go. Got this is how the file is named in version 7.10. Alright, let's minimize this. Let's double click it. Extracting files, temporary folder. Yeah. It makes a huge loud noise whenever I scroll through this options. Let's click install IAR embedded Workbench for msp430. Yes. Make sure you allow any kind of user account control, access control, whatever, UAC in short. Alright, click next, accept. Yeah, next. I would like to change it to the programs. Let's create something. Looks like we can't create a new folder here. It's too bad. Okay, let's click OK. That's too bad either. Alright, let me go to install directory, create a new folder called IAR embedded. Alright, that's the old one. Yeah, so I have created a new folder called IAR embedded. So now let's change it under program files, IAR embedded. Yeah, there we go. Click OK. Next, complete. Next, 7-zip, whatever. Next, install. It definitely takes a lot of time. It's around 500 megabytes in size, and okay, in case if you're wondering, say some kind of error pops up saying okay, the DLL is missing. In that case, what you can do is just type VC++ packages in your browser, and yeah, so one of the places where I usually get the redistributable packages get into PC, because they got a different versions bundled together. And see, don't download this one. I'm sorry, it's all stuck. Okay, here. Scroll down, you'll find something like Visual C++ redistributable packages. Click this. It's got different versions, 2003, 5 maybe. Yeah, see, couple of versions. These versions, once you install them, they will most probably eliminate most of the .dll errors. Click on download. Our IAR is still installing, so we'll show you right now. Alright, so I got one already downloaded, so I'll just go ahead with it. I have to just click proceed. Okay, click proceed. Okay, from now on it's pretty much you have to wait and it will download it. So let me close it because I got one already downloaded, and I'll go to extract. Alright. See the fix, just click the fix and read me first. Okay, try installing every one of them, both the 32-bit and 64-bit VC++ packages. That's cool. So you see here, you can see a different 64 bits and 32-bit versions. If you're a 64-bit Windows user like me, make sure you install both of them. And same way for 2008, I got them installed already, so you can go ahead and install. This will eliminate most of the .dll errors in Windows, even in games. Alright, so there we go. Still installing, I guess. Yeah, I guess it installed. Okay, it says remove any driver, any USB dongles before installing. Alright, no worries. Let's click yes. Let it install. Wow, looks like this one has got its own Visual C++ package. That's okay. See, that's why I told, because sometimes if that fails due to some error, and you'll end up with DLL errors, and our error fix is going to help. Okay, let's click finish. Oh, okay. The IDE opens automatically. That's cool. Executions. So this is how it looks for the first time. Right, if you want, you can go ahead and read the information. I'm just gonna close it for now. Alright. So for the first time, to upload a sketch to msp430, you gotta go to okay, let me tell you the proper way. The proper formal way is to create a new workspace first. You can go to project, create new project. I know only C, so I'll go to C with the main. Yeah, toolchain, we got only one option here, so nothing to worry about it. There we go. I already have a file because I have previously worked with IAR embedded Workbench, but that's okay. Let's click blank because the famous sketch, whatever. I guess it's changing the previous one. Alright, looks like it has by default added the include file with, include header file with all this other stuff. So this first line over here, as it stays, it's going to stop the watchdog timer. Alright, let's blink the you can see the LEDs. LED 1 and 2 are connected to port 1 pin 0 and port 1 pin 6, the P1.6 and P1.0. Alright, we'll be needing this. We will try to blink one of these LED. Since the blink is a continuously executable program, because we have to blink it again and again and again, we'll put them in while loop. So as we saw here, we have the to configure the port 1 pin 0 and pin 6 as output. So since we are going to control its direction, you can type P1 and for direction dir is equal to bit 0, which is the pin 0, plus bit 6. I'm sorry guys, since we have configured it as an output, yeah, so that's how you configure the pins as output. If you don't write this, then those pins are going to be treated as input. Yeah, so again we are going to control its output. Now we have set the direction as output. We have to control if the output is high or low. For that we'll go here, bit 0 plus bit 6. Let's first flash the LED, or at least light the LED. So this is not going to be a blink program, this is going to be just a light up LED program. For the first timer it's okay. So if you go ahead and click download and debug, ask for workspace, let's give a new one, say flash or lit. Alright, it's updating, starting debugger sessions. Okay, so there we go. For little advanced users, if you got to see what's happening inside the registers during this program run, when this program is running, you go to view, registers, register 1, 2, whatever, CPU registers, view group. So since we have port 1, I'm going to click port 1. See, we just configured the P1 out and P1 dir. See, this is little benefit in using IAR embedded workbench. Alright, you see I haven't plugged in the msp430, but still we are debugging, because IAR embedded workbench has an inbuilt simulator right now, and that is what we have uploaded the program to. We haven't uploaded the program to msp430 board. But still, even if you don't have msp430 board, you can try playing with this. Okay, let's run one statement at a time. Nothing changed. Now watch this. See, the registers value P6 and P0 changed. So okay, this is what a microcontroller is. You change the register values. That's how you talk or make things happen in a microcontroller. You have to change the register values associated with a particular pin, and you change the properties of that pin. Alright, okay, if you don't understand, that's okay. Alright, so let me put it to next statement. You see P1 out, it has been configured as 1, and the P0. Alright, so to upload this sketch to the actual board, we will need to make sure we have connected the body to board and right click. Okay, let's stop the debugger session. Click this X button. Okay, select this, options. Wow, we have msp430G2, not IF. So msp430G2553, yeah, there we go. And we had to do a couple of changes. You go to custom, no, not here, yeah, debugger, put it to fed debugger. Go here and go to L Protonic USB FPA because that's the one that worked for me, and change this to SPI by wire. Simulate, yeah, that's pretty much. Now click OK. Now watch this. We don't have the LED blinking right now, so I'm going to click download and debug button over here. So let me execute one statement at a time. This is called debugging. Still nothing happened. Yeah, both of our LEDs are blinking right now. Yeah, it's working. It shouldn't. Can you see it? It's blinking. I mean, we have just lit the LED. So if I go here, right click here and view group port 1, P1 out. Yeah, if I change these register values to 0, watch this. Watch what happens. See, another LEDs just went off. Let's change the other one. Press enter. Yeah, other LED went off. So let's rerun the program again. Alright, now both the LEDs are off. Alright, turn the flash off. Yeah, now on one statement at a time. Nothing happened. Well, watch this. Yeah, we got both the LEDs blinking. I mean, not blinking actually, as I laid up. So that's how you fiddle with registers inside in IAR embedded Workbench and make things glow. Alright guys, so that's how you play with msp430 in IAR embedded Workbench. If you're wondering where did I get all these wordings or syntax, it's pretty much here. You go to, just click on plus C here, and you go here, IO430G253. See here, watch this. You got a different declarations. See the special functions. These are status register bits of CPU. We can control them using these. One interrupt flag. There we go, P1 DIR. So that's how you make things work. But if this wasn't satisfactory, because I don't feel this is satisfactory. So alright, so you go to your browser again, msp430 family guide. Alright, type this and download the PDF. First PDF usually works. It's around 3 MB. That's a weird sound. Alright, and we open it. You see, scroll down to digital IO registers. You see, this one has got everything clear cut. So P1 DIR actually controls the port 1's direction, and P1 out actually controls the P1 out, port 1 out direction. To get more detailed and look, I guess, there we go. Output registers. Bit 0 output is low, bit 1 output is high, direction registers. Bit 0, the port pin switched to input direction, the port pin is switched to output direction. So let me come back here and just tell you one last thing. So what we actually see here, the P1 out is actually a register. Alright, it has got 8 bits, and the bit 0 actually controls the P10 pin, the GPIO pin. So let me, if I turn this to 0, see what happens. The red LED has gone blind, and same way put this one 0. So these are the registers actually associated to these pins. See, that's how we make things happen in microcontroller. We talk to microcontroller using registers, and yeah, IAR Workbench really does that. So stay tuned guys for more videos on how to use timers and to actually blink the LED. I'm sorry, next time I'll surely show you. Thanks for watching. Do let us know what you think about this video, okay? Thanks for watching.